Let ABC be an equiangular prism in which angular prism is equal to 60 degrees. Let there be a monochromatic ray following normal to the face AB of this prism at the point X. Whenever any ray will fall normal to the surface, angular incidence will take it as 0 degrees. At the point X, since light is trying to go from air to glass, we can apply Snell's law at the point X. Here we can put the value for refractive index of air equal to 1 and the value for I equal to 0 degrees. We will be getting the value for R1 equal to 0 degrees. Since I is equal to 0 and R1 is also equal to 0, it means that the ray will go straight undeviated through the prism at the point X and it will be meeting the other face at the point Y. If you draw a normal at the point Y, we can calculate the value for R2 by using a simple formula. A is equal to R1 plus R2, A which is equal to 60 degrees, R1 it already proved it is 0 degrees, so we can calculate R2. R2 we will be getting it equal to 60 degrees, which is same as that of angular prism. If R2 is equal to 60 degrees, at the point Y, the ray can follow three different ways. It can go out in three different ways. Either it can go out of the prism, we can call it as ray 1, or it can graze along the surface of the prism, we can call it as ray 2, or there can be total internal reflection, we can call it as ray 3. Now at the point Y, the light will be following which path will be depending upon the three conditions. What are these conditions under which the ray will be adopting path 1 or path 2 or path 3? We'll take up these conditions one by one. Now at the point Y, the angle of refraction is 60 degrees and we say that the light is trying to go from glass to air at the point Y. We can apply Snell's law at the point Y in which we can put the value for R2 equal to 60 degrees and refractive index of air equal to 1. So from here we will be getting the value for sin E as 3.2 times refractive index of glass. Now the first condition was that emergent ray was going out of the prism and we say that the angle of emergence is defined. When angular emergence is defined, sin E will have a value which is less than 1, and if you put the value for sin E, we will be getting refractive index of glass is less than 2 upon root 3, because this is the condition when the emergent ray will be obtained. Then we have got the second condition, that emergent ray will graze along the surface of the prism, in which the angle of emergence will be equal to 90 degrees, and sin 90 is equal to 1. That means sin E will become equal to 1. And if you put the value for sin E, we will be getting refractive index of glass is equal to 2 upon root 3. Then we have the third condition, that there will be no emergent ray. The light will be reflected back. There will be total internal reflection. We say that the angle of emergence is not defined, and in this case sin E will have a value which is more than 1, and if you put the value for sin E, we will be getting refractive index of glass is more than 2 upon root 3. Now these three are the conditions. One condition is that refractive index can be less than 2 upon root 3, in which emergent ray will go out. Refractive index of glass is equal to 2 upon root 3, emergent ray will graze along the surface of the prism. The refractive index of glass is more than 2 upon root 3. In this case, there will be total internal reflection. Thank you.